Welcome to this explainer. Today, we're going to demystify the Model Context Protocol, or MCP. This is rapidly becoming the absolute ultimate standard for connecting AI models to your external systems. If you've been wondering how to easily get large language models to actually interact with your specific data without writing endless custom code, well, you're in the exact right place. Let's dive right into this. Here is our roadmap for the next 10 minutes. We'll start with the AI integration matrix, cross some conceptual bridges, map out the architecture and flow, look at tools, resources, and prompts, touch on transport and security, and finally, wrap up with the open source ecosystem.
All right, part one, the AI integration matrix.
Look, we all know large language models are ridiculously smart, right? But they have this massive baked-in limitation. Their knowledge is totally sealed off at training time. If you ask an AI about a local file, a specific row in your company's database, or literally an email you just got this morning, it either completely halts, or even worse, it just guesses and makes something up. It's basically blind to your live data. And historically, bridging that gap has fallen 100% on the developer. Actually, this problem feels kind of familiar. Remember the matrix from hell that early Kubernetes adopters faced? Trying to perfectly match different services with specific OS versions and dependent libraries? Well, today's AI developers are dealing with a very similar nightmare. Imagine having M different AI clients, like chat apps or IDE assistants, multiplied by N different external tools, like databases or internal APIs. Without a shared standard, it's a mess. You end up writing a fragile, totally custom integration for literally every single client-to-tool pair. Think about it. If 3 AI apps need 5 internal tools, you are suddenly building and maintaining 15 separate integrations. Crazy, right? But what if both sides just spoke the exact same language? By shifting to a protocol standard, that whole integration surface drastically shrinks from M times N custom adapters down to just M plus N protocol implementations. Enter MCP. Introduced by Anthropic, the Model Context Protocol is an open-source standard that acts exactly like a universal USB-C port for AI applications. It's a real game changer. Just as USB-C gives us a standardized way to plug in devices, MCP provides this incredibly clean, universal connection between AI apps and external systems. It completely eliminates the burden of that chaotic web of custom adapters.
Moving on to part two, conceptual bridges.
If you've ever built anything with React, you know how the Context API elegantly shares a global state, saving you from the absolute nightmare of manual prop drilling. Well, MCP operates on a remarkably similar philosophy. It avoids what we might call integration drilling by providing a standardized state and tool layer. It seamlessly provides context to any model without all that manual API wiring across your entire stack. We can also compare it to standard web protocols you're probably using every day. While REST is perfect for your basic client-initiated CRUD operations, and WebSockets absolutely excel at pushing continuous real-time data from server to client, MCP fills a completely new role. It is uniquely built to expose tools, resources, and prompt templates securely straight into an AI's context window. It is truly purpose-built for the AI era.
Okay, part three, architecture and flow.
So how does this actually work under the hood? The architecture relies on 3 key players working in perfect harmony. First, there's the host. This is the application the user interacts with, containing the AI model itself. Inside that host sits the client, which manages all the plumbing and translates the model's requests. And finally, you have the server, the actual bridge executing actions on your external systems. Let's trace a real request to see this in action. Say you ask an AI to summarize Q2 revenue in an email. Step 1, the model identifies it actually needs external data. Step 2, the client checks its registered servers. Step 3, the completely independent database server runs the query and gets those numbers. Step 4, the client translates this back. And Step 5, the model uses that data to call the email server to draft the message. The coolest part? The database and email servers do all the heavy lifting without ever knowing the other even exists.
On to part four, tools, resources, and prompts.
MCP servers expose 3 distinct types of capabilities. First up, tools. These are active, callable functions that actually compute results or take real action. Second, resources. These are passive, readable data contexts, like a text file or a specific database record. And third, prompts, which are reusable execution templates provided by the server to guide how the AI should approach certain tasks. Now, you might be wondering, why go through the trouble of mapping them out differently? Well, it all boils down to risk. Reading a passive resource, like a text file, that's pretty low risk. But calling an active tool that, say, writes data directly to your production Postgres database, that requires entirely different security constraints. By separating them, MCP lets you apply strict, distinct authorization policies to each type of action. Which brings us to Part 5, Transport and Security. MCP communication is split into a JSON RPC data layer and a transport pipe, which basically gives you two main deployment options. You can run locally through standard input/output or Studio, where the server runs as a sub-process. That gives you maximum privacy and speed. Or you can run remotely via streamable HTTP with server-sent events, which is awesome because it lets you scale independently and handle multiple clients at the exact same time. But with great power comes great responsibility. Because MCP gives AI real tangible reach into your live systems, security is absolutely paramount. Best practices here mandate that you tightly validate authentication tokens, bind sessions to real human identities, and restrict server scopes. And this is crucial. You absolutely must mandate explicit user consent before an agent takes any destructive action. A malicious server handing out unvetted internal IPs is a complete nightmare, so sandboxing those local servers is just a non-negotiable. All right, final section, Part 6. The open source ecosystem. Just as open source initiatives rely on community contributions to thrive, MCP is absolutely exploding right now. And the best part? You don't have to build everything from scratch. There's already a massive, thriving ecosystem of pre-built, community-driven MCP servers for platforms like Slack, GitHub, and Postgres. The community is literally doing the heavy lifting for you. And because MCP is heavily supported by the major AI players and dev environments, we're talking Claude, ChatGPT, VS Code, Cursor, the mantra here is truly write once, integrate everywhere. You just build your custom server one time and boom, you instantly unlock your organization's data across the entire AI landscape. No new adapters required. So, you now understand the mechanics, the architecture, and the immense scalability of the AI industry's new universal port. You are no longer limited by the static training data of language models. The only question left to ask is this. If an AI can now securely read your databases, control your tools, and act on your behalf across your entire infrastructure, what's stopping you from building the fully autonomous agents of tomorrow? Thanks for joining me for this explainer on the Model Context Protocol.